Okay, think about this for a second. By 2050, that's not too far off, we'll probably need something like 70% more food.
Yeah, 70%. It's a staggering number.
And your first thought might be, well, irrigation, right? You know, those big green fields, water pipes everywhere.
Sure, that's the image most people have.
But what happens when water gets tighter? When those resources are stretched, that's where this other massive part of our food system comes in, the rain-fed farms.
Exactly. They're often kind of overlooked, aren't they? But yeah, a huge amount of food production depends entirely on rainfall.
And these systems, they're facing, well, bigger and bigger challenges.
Definitely. Climate change, water scarcity,
Yeah.
it all hits them hard.
Which brings us right to what we're diving into today. It's this incredibly comprehensive book, Rain-Fed Farming Systems.
Ah, yes, the one edited by Toe, Cooper, Partridge, and Birch.
That's the one. Now, it's not exactly beach reading, but it's seen as a really ambitious and necessary effort trying to survey rain-fed farming all across the globe.
It really is. It sort of picks up where some older, influential books on farming systems left off, the ones that are now out of print.
Right. So this book tries to synthesize all that knowledge.
Yeah.
Everything from like huge commercial farms in developed
To
countries.
the much smaller, sometimes subsistence level farms in the developing world, it covers a huge range.
It gives you that broad lens,
Mhm.
helps understand the common ground, but also the unique problems in different places.
Exactly.
So, look, if you've ever thought about how we're actually going to feed everyone as water gets scarcer, or, if you're just curious about farming beyond those big irrigation schemes,
Then this is definitely for you.
yeah, we're going to try and boil down the key ideas, the pressures these farmers are under, wacky weather, soil issues, tough markets, and also some of the really cool innovations happening.
Innovations to keep things productive, profitable, but also sustainable.
Right. So our mission, basically, is to give you a good handle on this vital topic, but without drowning you in technical stuff.
Precisely. We want to shed light on what these systems are, the stresses they face, and what the future might hold.
Okay, let's get into it. The book starts by defining what we mean by rain-fed. Essentially, systems that usually get, let's say, less than ideal rain.
Yeah, and they have significant dry spells during the growing season, times when lack of water really limits how much they can produce.
That's the key point. And it's important, as you said earlier, we're not really talking today about those places with generally plenty of rain.
Right. Not the tropical rainforests or, temperate zones like New Zealand or much of Europe.
Our focus is squarely on areas where getting enough water, managing that water, is a constant critical thing.
It's a really crucial distinction. Derek Byerly mentions this in the foreword, doesn't he? The absolute core challenge is making the most of every drop of moisture you do get.
While dealing with massive climate risks.
Exactly. High risk, unpredictable weather. It's a whole different ballgame compared to reliable rain or irrigation.
So the book then kind of maps out the different types of rain-fed systems globally. Chapter 2 does this, right? Harrington and Toe.
That's right. It gives you that sense of diversity without going super deep into every single region just yet. It sets the stage.
So you understand that a rain-fed farm in, say, West Africa could be
Yeah.
totally different from one in Canada or Australia in terms of how it runs, the challenges.
Completely different contexts, yeah. And this whole topic is just so timely, isn't it?
Definitely. As irrigation water gets scarcer or more expensive.
The focus has to shift, doesn't it?
Yeah.
How do we boost and maintain production in these rain-fed areas? They're going to be absolutely critical for food security going forward.
Okay, here's where it gets, I think, really interesting. The book hammers home this idea of a systems approach, right from chapter 1.
Yes, Toe and the others emphasize this strongly. It's fundamental.
It means not just looking at one crop, like wheat, in isolation.
Exactly. You've got to look at the whole farm as an interconnected system. Soil health, water management, the crops, maybe livestock.
But also the economics, the social side.
Absolutely. The economic reality, the social context the farm sits in, it's about seeing the entire picture. The book really pushes for bringing together insights from natural sciences and social sciences.
So instead of just, here's a new drought-resistant seed, it's more like, how does this seed fit with the soil, the water, the markets, the climate here?
Precisely. How does it interact with everything else?
And through that lens, the foreword talks about 3 key things for successful systems: sustainability, resilience, and equity. Can you unpack those a bit in this context?
Sure. Sustainability is basically the system's ability to keep producing over the long haul without wrecking the natural resources, soil, water.
Okay, makes sense.
Resilience is about bouncing back. How
Yeah.
well can the system handle shocks, like a bad drought or, a sudden price crash for their crops?
Right. The ability to withstand stress.
Mm-hmm. And equity is about fairness. Fair access to resources, fair distribution of the benefits among everyone involved or affected by the farm.
Got it. Those three together kind of form the foundation.
They really do. They run through the whole book.
So Part I then dives into all these different disciplinary areas that affect rain-fed systems. You mentioned climate risk.
Yep. Water management, how plants get nutrients. Chapter 5 by Ryan specifically mentions the Mediterranean, which is super relevant for water limits.
Right. Then soil biology, technology changes,
Yeah.
even managing weeds, diseases, pests. It's like a whirlwind tour of farm science.
It is, but what's key is how the book links them all. It's not just separate chapters on soil, then water, then pests. It shows how they're all interconnected, how they influence each other.
Like the soil biology chapter.
Yeah, Gupta et al. On soil biology, it stresses how microbes and stuff in the soil are crucial for nutrients and holding water, both absolutely vital when water's scarce.
And it doesn't stop at the science, right? There are chapters on economic, social factors.
Definitely. Chapter 12 by Cooper looks at how market access, labor, even cultural norms shape what farming systems are actually possible and sustainable in a place.
And then there's designing systems, chapter 13.
Yeah, Pearson's chapter tries to pull all these threads together into a kind of practical framework for designing or improving systems.
There's even one specifically on soil organic carbon, especially in Australia. That sounds quite specific but important.
Oh, very important. Chapter 14, Hoyle et al. They highlight just how critical soil carbon is, particularly in Australia's often nutrient-poor, dry conditions.
Why is it so critical there?
Well, think of it like a sponge in the soil. More carbon means the soil holds water better, releases nutrients better, both essential when rain is scarce and unreliable.
Okay, so Part I lays all this groundwork, these principles. Then Part 2 takes us traveling, showing how diverse these systems are globally.
Right. This is where you see those principles playing out and being adapted in wildly different places, different climates, different economies.
The book highlights specific regions, like West Asia and North Africa, the Wana region, obviously very dry.
Exactly. Ryan's chapter 15 focuses on that. The key challenge is just very low rainfall. So adaptations include things like drought-tolerant crops.
Makes sense?
Water harvesting techniques to catch every bit of rain, and farming methods that minimize evaporation from the soil.
They must have a long history of dealing with this.
They do. There's a huge amount of traditional knowledge there about water conservation that modern science is really starting to appreciate and learn from.
Then it moves to South Africa. A couple of chapters mention emerging farmers, land reform in Limpopo. Sounds complex.
South Africa is a fascinating case. Chapters 16 and 17 highlight this. You've got the usual challenges of rain-fed farming, plus these really significant social and economic layers. Integrating new farmers, the legacy of land reform. The systems have to adapt to all of that.
What about the Canadian prairies? I'm guessing less about total water scarcity, maybe more about cold and short seasons.
You got it. Lafon and colleagues in Chapter 19 detail this. Short growing season, harsh winters. So adaptations include zero tillage, helps keep moisture and heat in the soil. And choosing crop varieties that mature fast before winter hits. And actually, their widespread use of zero-till has had big benefits for soil health, carbon storage. Lessons there for others.
In the U.S., obviously huge and diverse.
Yeah, Chapter 20 by Franz Lubers et al. Really shows that range. From the humid east to the dry Great Plains, it underscores that you need tailored approaches, region by region.
One that jumped out at me was the Loess Plateau in China. Sounds quite specific.
It is. Chapter 23, Huang et al. It's a large area, semi-arid, historically plagued by terrible soil erosion. So the chapter likely talks about the massive efforts there on soil conservation, water management, really interesting case of large-scale intervention.
And then back down under southern Australia. Developed agriculture, but still grappling with variable rain.
Chapter 26, Kierkegaard et al. It really shows how dynamic things are there. Even with fancy tech, farmers are constantly adjusting to drought risk, market shifts, environmental concerns. It proves that even in advanced systems, adapting to rainfall is still absolutely fundamental.
So after that world tour, Part 3 changes tack. It looks at how these systems are evaluated and, crucially, how they're being improved.
Yeah, this is moving beyond description into, okay, what are the strategies, what innovations are making these systems better, more productive, more profitable, more sustainable?
It kicks off with something basic but essential. Monitoring and evaluation. You can't fix what you don't measure.
Exactly. Seymour and Wicks in Chapter 27 make that point strongly. You need systematic tracking to see what's working, what's not, and if the changes you make are actually helping over time.
Then we get concrete examples, like increasing precipitation use efficiency for wheat in Western Australia. That sounds very practical.
It is. Chapter 28 by Turner explains how farmers there, in a really dry, variable climate, have gotten much better at turning every millimeter of rain into actual wheat yield.
How do they do that?
It's often a mix of things, like planting at just the right time, using fertilizer smarter, choosing wheat varieties that are just really good at coping with dry spells.
Interesting. Another example mentioned was soybean expansion in Ontario. That sounds like adapting to markets and environment.
That's what Chapter 29 by Hume and Pearson suggests. Bringing soybeans into Ontario systems was partly market-driven, sure, but it also had environmental pluses, like soybeans fixing nitrogen in the soil.
The book doesn't shy away from the people side either, does it? Looking at mixed crop livestock farms, how drought affects decisions.
No, it doesn't. Chapter 30 by McGuckian and Rickards really brings in that human dimension, how farmers' social networks, their individual choices, the support they get from extension services, how all that shapes their response to something like a long drought. It's not just about the technology.
We even get a deep dive into one specific farm's evolution on the Canadian prairies. That must offer some grounded lessons.
For sure. Chapter 31 by Day gives that long view, seeing how one farm adapted over years, the actual choices made. Real-world examples like that are often the most useful.
There are also examples of improving traditional systems, like crop pasture mixes and the rise of conservation agriculture. That's a big buzzword, isn't it?
It is, and for good reason. Chapters 32, 33, and 34 cover these. Ransom and Trapnell look at boosting crop pasture systems with lucerne. Sayre and Govertz discuss conservation ag, like no-till, cover crops, rotation, especially its benefits in developing countries.
And linking that with precision ag.
Yeah, Branson in Chapter 34 looks at how you can combine conservation principles with precision tech, like GPS guidance for tractors, variable rate fertilizer application, that sort of thing.
And this section wraps up looking at risk management, dealing with that climate uncertainty we talked about.
Absolutely critical. Chapter 35, Nguyen et al. Uses Queensland, Australia as an example. It shows how proactive strategies and sophisticated decision support tools can help farmers make better, faster decisions when faced with unpredictable rain or markets.
Okay, moving into part 4. This shifts focus, again, looking at research, extension, getting knowledge out to farmers, and how the whole farming systems idea has evolved in those fields.
Right. This part explores how we learn about these complex systems through research, and then how that knowledge gets shared and applied through extension services. And also how research and extension themselves have changed to better meet farmers' needs.
It mentions farming systems approaches becoming more common in research and extension. That seems logical, given everything we've said about interconnectedness.
It does. Chapter 36 by Lawrence traces that shift, moving away from studying things in isolation towards a more integrated systems view, recognizing that you can't just tweak one thing without affecting others.
And in Australia, it looks at the role of consultants, farmer groups, decision support tech in helping farmers make choices.
Yes, Chapter 37 by Long and Cooper describes that landscape. Farmers drawing on consultants, collaborating in research groups, using increasingly sophisticated software tools to help manage complexity.
But then it contrasts that with Tanzania. Chapter 38 sounds fascinating, where culture and science meet in extension work. Really highlights the need for context.
It really does. Polkinghorne's chapter is a great example. It shows how, in places like rural Tanzania, long-standing cultural practices and local knowledge can be incredibly powerful, sometimes more so than purely scientific advice. Bridging that gap is essential for effective extension. One size definitely does not fit all.
And finally, in this part, updates on no-till tech, managing soil compaction, and how places like Wana are adopting no-till. Technology keeps advancing.
Chapters 39 and 40 cover that. Ongoing improvements in no-till equipment and practices crucial for saving water and soil health. And seeing successful adoption in challenging regions like Wana really underscores the value of these approaches where water is scarce.
Now, Part V sounds incredibly valuable. It turns the mic over to the farmers themselves, right?
Yeah.
Case studies based on their experiences.
Exactly. This is where it gets really grounded. Farmers sharing their own stories, how they've tackled challenges, innovated, kept their farms going, often over generations. These first-hand accounts make everything else in the book feel much more real.
We get a comparison of 3 farms in South Australia, all with different rainfall levels. That must really show how strategies have to adapt locally.
It does. Chapter 41 by Krauss and Cooper provides that direct comparison. You can clearly see how farmers adjust their whole approach based on how much rain they typically expect.
There's also a story about farm expansion and diversification, again in South Australia. Shows farmers adapting to economic shifts too.
Right. Chapter 42 by the Roads. It's a narrative of how one farm grew and added different enterprises over time. Shows the kind of business savvy and adaptability needed to thrive under variable conditions.
And another South Australian one about moving from traditional ways to more innovative ones. Seems like a recurring theme, embracing change.
Chapter 43 by Wormald tells that story. A farm deliberately adopting new tech and practices to boost productivity and sustainability. It's a conscious shift away from older methods.
In examples from New South Wales, Victoria, different mixed farming setups, adapting to seasons and markets.
Yeah, chapters 44, 46, and 47 give insights into mixed farming in different Australian contexts. Integrating crops and livestock often builds resilience, helps buffer against climate and market swings. Chapter 45 specifically focuses on one farmer's journey with developing and adopting no-till in northern NSW, the practical side of it.
And a Canadian perspective too. 30 years of no-till in Saskatchewan. That's a serious long-term commitment.
It is. Chapter 48 by Halford offers that vital long view. What does it look like after 3 decades? The sustained benefits, any challenges that emerge. Really valuable practical experience there.
And Part V finishes with more case studies from across the U.S., just reinforcing that diversity.
Chapter 49 by Franz Lubers does that. Shows the variety across U.S. regions, different climates, soils, practices, and the innovative ways farmers are managing their rain-fed systems.
And then finally, Chapter 50 pulls it all together. The editors summarize the key takeaways from this massive survey.
Exactly. Toe, Cooper, and Partridge wrap it up, highlighting the main themes, the big conclusions about the principles, the challenges, the innovations in rain-fed agriculture worldwide. It's a neat synthesis.
So as we kind of wrap up this deep dive into rain-fed farming systems, wow, it's clear that feeding everyone with less water is, well, a massive challenge.
Yeah.
And rain-fed farming is a huge, maybe underestimated piece of that puzzle.
Absolutely pivotal.
And it really comes down to adaptation, doesn't it?
Yeah.
Constant innovation and really understanding the farm as a whole system. That seems crucial for keeping these systems going.
Productive and sustainable. And it's actually, quite encouraging to see the progress being made. Despite all the difficulties, farmers and researchers are doing some amazing work.
Definitely. And understanding these systems, it gives you, the listener, I think, a really valuable context for thinking about global food security, environmental sustainability.
And just how interconnected everything is. The resilience and ingenuity of farmers facing these huge pressures is really something.
Yeah. Thinking about all the different challenges, all the diverse solutions we've touched on from the book,
Yeah.
it makes you wonder, doesn't it? What's going to be the single biggest factor determining if we succeed in feeding everyone sustainably in the next few decades?
Is it going to be some new technology? Or maybe big shifts in how we consume food?
Or perhaps policy?
Yeah.
Actually getting governments to really support sustainable rain-fed farming globally.
It's a big question. Definitely something to chew on.